A function f is a quadratic function if you have the following. So what makes it quadratic is a square term. That's what makes it quadratic. A, B, and C are real numbers. So the vertex of a parabola is given by this formula here. So parabola will look something like this. This would be the vertex, the lowest point, or it can also be opening up downward, which would mean that the vertex would be on the top, a maximum point. So to find the vertex, you use this formula, x equals negative b over 2a. There's another form that the parabola can be in. It's called the standard equation, and that's given by this form. It's also quadratic, as you can see by the square term. And what's nice about this is that hk is the vertex, and hk is given by this number and this number. And it also tells you if it's opening upward if a is positive, or downward if a is negative. Same with up above this form. If a is positive, then it opens up upward. If a is negative, it opens downward. Let's look at this first exercise. Find the standard equation of any parabola that has vertex negative 2, 7. So since they're using the word or the phrase standard equation, that means we have to go with this one. So we can do that by simply plugging in h and k. So you have f of x is equal to a x minus h squared plus k. And then this double negative here turns into a plus, so we can simplify that into f of x equals a x plus 2 squared plus 7. And that would be the final answer. We can't determine a because we're not given any other information. Sometimes they'll give you an additional information which you will be able to use to figure out what a is, but in this case we have to keep it general since we don't have any additional information. So for this one, they want us to express it in the standard form again. So what we can do is first find the vertex, which is hk. So to find the vertex, we have to use the formula x equals negative b over 2a. All right, so a is 5, b is 20, c is 14. So if you plug those values in, you should get negative 20 over 2 times 5, which is negative 20 over 10, which is negative 2. So that tells you the x-coordinate, and we still have to find the y-coordinate of the vertex. In order to find the y-coordinate, you would simply plug in x, negative 2 in for x. And that's all you would need to do. So f of negative 2 is 5 times negative 2 to the second, plus 20 times negative 2 plus 14. And we can do this. Let's see, that would be 4 times 5 is 20 minus 40 plus 14. That's going to be negative 6, I believe. It's negative 20. Yeah, negative 6. So that is the y-coordinate of your vertex. And the nice thing about going from this form to this form is that the a is actually the same a, so you don't have to do anything special to figure out what a is. We already know that it's 5. So our final answer can be written as f of x equals a, which is 5, parentheses x minus negative 2 squared minus 6 for the k. And same as before, you have double negative here, so that becomes a positive. And that is our final answer. That's how you go from this form to this form. Okay, for this one, they want us to use a quadratic formula to find the zeros. So let's do that first. So once again, a is negative 12, b is 11, c is 15. Quadratic formula is negative b plus or minus square root b squared minus 4ac all over 2a. In this case, that would be negative 11 plus minus 11 squared minus 4 times negative 12 times 15. all over 2 times negative 12. And if we work all that out on our calculators, we should get getting 841 under the radical. And let's see if that is a perfect square or not. And it is. It is a perfect square. It's 29. Now we have to break this up into 2 separate problems, plus and minus. And if you work this out, you should get, let's see, what is that going to be? 29. So you should get negative 18 over 24, which we can simplify by a factor of, that's going to become 3/4, negative 3/4 actually, if you simplify. And then the top would become 40 over 24. Double negatives become positive, and we can simplify that by that's going to be, we can simplify that by 4. 4 gives us 10. Actually, can we do a higher number? 8, possibly? Yeah, 8. That's going to be 5. And 8 divided by 8 is 3. So 5/3 are the 2 solutions, or the 2 zeros. All right. X equals, I should write. All right, now to find the minimum or maximum, we can determine which of the 2 it's going to be based on A. Since A is negative, that means it opens downward, which means that gives us a maximum value. Maximum, because A is negative. All right, so we need to find the maximum by using the vertex formula. So negative B would be negative 11 over 2 times negative 12, which is going to be double negative, which is going to be a positive. So let's see, 11 divided by 24 is going to be a decimal. So that's going to be approximately 0.46. And once again, to find the y-coordinate, you would substitute that in to the original function in order to get the y-coordinate. So that's going to be negative 12 times 0.46 squared plus 11 times 0.46 plus 15. So if we do this on our calculators, we should get getting 17.5 approximately. So that is our vertex. Now for the sketch. So to sketch this, let's start with the vertex. So 0.46, 17. We're going to have to scale this by 5, 10, 15, 20, or how about 3, 6, 9, 12, 15, 4, 8. We're going to have to go by 4s. So I'm going to call that 4, 8, 12, 16, 20. I'm going by 4s. All right, and so now if you graph this, you're going to go 0.46 to the right and then 17.5 up, which would be approximately here. Doesn't have to be super perfect. All right, and then the zeros are negative 3/4, which would be negative 0.75, and 5/3, which is 1.66. About right there. And there's our upside down parabola. So that's how you would sketch that quadratic equation or function. Find the standard equation of a parabola that has vertex. So we're given the vertex, which is h comma k. And then they do give us an additional point, which is going to allow us to find out what a is. So once again, let's plug this into our vertex form. So if you substitute h, a for h, 2 for h, you're going to get x minus 2. and then 3 for k, you're going to get plus 3. Now we can use this information when x is 5, y is 1, or f of x. So f of x is 1, x is 5. Now we can solve for a. This is going to be 3 squared, which is 9. So we have 1 equals 9a plus 3. And now we can solve for a. So now that we have a, now we can finally write our final function as f of x equals negative 1/9 x minus 2 squared plus 3 is our final answer. So when they do give you an additional point, that means you're going to be able to find out what a is. If they do not give you an additional point, then you would just leave that as a. An object is projected vertically upward from the top of a building with an initial velocity of 144 feet per second. Its distance s of t is in feet above the ground after t seconds is given by this equation. Find its maximum distance above the ground. Okay, so, well, that's not a good picture. Let's draw that one more time. There we go. So someone is standing here, and they're throwing an object, and it's going up, and then it's going down. We want to find its maximum distance above the ground, which means we need to find the vertex. That would be the maximum distance above the ground. So the vertex, once again, is given by x is equal to negative b over 2a. So negative 144 over 2 times negative 16. Since a is negative 16 and b is 144, let's see what we get. So that's going to be 144 divided by 32 is 4.5. And once again, we need to find the y-coordinate, and we do that by substituting 4.5 into our function. So that's going to be s of 4.5, which is negative 16, 4.5 squared, plus 144 times 4.5 plus 100. So on the calculator, this is going to be 424. Oops, not 5, 424 feet above the ground. So that is the answer to that part of the question. All right, find the height of the building. So we're supposed to assume that the height of the person is negligible or so small that it's just 0, because they don't tell us the height of the person. So what you're supposed to do to find the height of the building, that means you want to know what the distance is from here to here. Well, that happens when the time is 0. At 0 seconds, the object has not been thrown yet. So that means that at time 0, that's going to tell us the height of the building. So that is how you're supposed to do this. Time equals 0. At the moment right before the person throws the object, that's going to tell us the distance from here to the bottom. And once again, we're assuming that the person's height is basically 0 because they don't tell us how tall the person is. So if you substitute 0 into t, you're going to get you get 100. So that's 100 feet.